Hi all, welcome to my channel Science for All by PK. Today we are going to discuss about sound. Sound is the basic thing which we see and experience on daily basis. It can be in the form of talking, listening music, watching movies or breaking a glass. Now, what is sound? Sound is a form of energy which is produced by vibration of an object, and it creates sensation in our ear. That means the source of sound is vibration. When sound has to be generated, some vibration has to be done. Something has to vibrate. Say for example, when we play guitar, that string vibrates. And first line says sound has energy. As we said, sound has energy. Energy is the capacity to do work. Is it possible that sound can do work? Yes, we will see in an example practically. It's here. So guys, you have seen sound has energy and which is able to do work. We saw that in the small clip that sound was able to move the paper. Now, what is sound? How it propagates? How it goes from one place to another place? Sound is a form of energy and it's a wave. Wave is a disturbance in a medium which can carry energy from one place to another place. Say for example, if there is a still water and I put a stone here, then we see there is wave generated in the water which are seen in the form of ripples. Now that means energy from this point is propagating or traveling outwards. One interesting question: if I put a piece of paper and when there is a wave in a still water because of stone, whether this paper will be at the same place or it will move along with the wave? The answer is very interesting. This paper will not move from its position, it will go only up and down, but it will not move in this direction. That means medium is not moving. When wave propagates, medium doesn't move. Only disturbance happens in the medium and the energy moves from one place to another place. Waves are of two types: mechanical wave and electromagnetic waves. What are these waves? The basic difference between these two waves is mechanical wave needs medium to travel and electromagnetic wave does not need medium to travel. Is it possible that wave can travel without medium? Yes, we have example of radio frequency wave or RF waves. That is how we are able to communicate with the satellites which are outside of Earth's environment or in vacuum. Say for example, Earth is here and there is an atmosphere and moon is somewhere here. Satellite can be somewhere here or going to Mars very far, but still we are able to communicate. These are through radio waves. Now coming back to mechanical waves, sound is a classical example of mechanical waves. It needs medium. The another example is wave on a rope. If rope is tied one side on a fixed point and other side I just move it like this, then you can see that the wave moves, but rope is not going, that energy in the form of disturbance moves. So sound is a wave, has energy and is a mechanical wave. Now let me show you the graphical representation of the wave. So on the y-axis we have amplitude and on the x-axis we have time. So with time, amplitude is having variation. We can notice one thing, that this portion of the wave keep repeating again and again. If you see, this is going up and here also it is going up, then it goes to maximum position, then it comes down, again 0, then takes a negative value, and here. So same thing is keep repeating again and again. That means this is kind of a cycle which keep repeating. So this portion is called one cycle. This cycle keep repeating, and the number of cycles repeated in 1 second, or we can simply say number of cycles in 1 second, is called frequency of the wave. That is called frequency of the wave. It is denoted by small n or small f. Now in this diagram, if I take up to this point, time is 1 second. Say for example, from here to here it's 1 second, then it has 2 cycles. That means the frequency of this wave which we are seeing here is 2, and the unit is hertz. So I can write 2, it is written as capital H and small z, or hertz. Now another interesting parameter, and which is very important, is time period. So time period is, we have seen how many cycles are there in 1 second. Now we will see how much time is taken by one cycle. When one variation is happening, there is some time, and this time is denoted by capital T and is called time period. So in this particular graph, there are 2 cycles in 1 second. That means time taken in 1 cycle is half of the second, or 0.5 second. Now if I see closely, there is a relationship between T and F. Here 2 and here 1/2. So we can say F equal to 1/T. Unit of frequency is hertz and unit of time period is second, and the relationship between F and T is F equal to 1/T or T equal to 1/F. Now if I change x-axis with distance, so I have replaced time with distance. In this case, now this axis is showing distance, and if I see distance up to here, up to this point, is distance traveled by wave in 1 cycle. Distance traveled by wave in 1 cycle, and this is called wavelength. So what is wavelength? Wavelength is distance covered by or traveled by wave in 1 cycle, right? Now, and this is denoted by lambda. So this is wave length and denoted by lambda. This is the symbol for wavelength. Now we have got 3 parameters of wave: frequency, time period and wavelength. Now if V is the velocity of the wave, then V equal to F or N, depending upon how we are representing frequency, V equal to F into lambda. This is the relationship. Velocity of the wave is equal to multiplication of frequency and wavelength. Now we are going to discuss about two more important parameters of sound. One of them is loudness and pitch. Loudness is amplitude of the sound which is felt by our ear. That means if a sound has a smaller amplitude, and another sound of the same frequency has bigger amplitude, that means this sound is louder. When sound is louder, it has more energy, because we can see this area covered by wave is more. When energy is more, it can travel longer distance. So if we need to send energy to the larger distance, we have to make sure it is loud enough. And the pitch is the way our ear feel for the frequency. If frequency is high, it is called high pitch, and if frequency is low, that is called low pitch. Say for example, a big drum, when it produces a sound which is of low frequency, or we can say low pitch, and the sound of bird which is relatively higher frequency is high pitch sound. Now very important and practical thing which happens in our life, when we speak in a empty hall which is big enough, or in front of a wall which is little far from us, is we hear echo. What is echo? Echo is when we hear our sound back after some time. So this is called echo. One is the sound produced by source and then it comes back. How it comes back? Suppose there is a big wall and I am standing here. When I make noise, this travel here reflects by this wall and comes back to me. If there is enough gap between the production of sound and the sound which is returning back, then I hear echo. Our ears can distinguish between two different sounds if gap between them is more than 0.1 second. Now, normally the velocity of sound in air is around 340 meter per second. Now, if time taken in this travel is 0.1 second, then we can find what is the distance required to get echo. Say suppose this distance is d. So d meter is traveled while going and d distance is traveled in the returning back. So total distance covered in this process is 2d. So total distance covered is 2d, and we know that speed equal to distance divided by time. Now average velocity of or the speed of sound is 340 meter per second and distance is 2d, and we are calculating distance for 0.1 second. So that means 340 multiplied by 0.1 equal to 2d. This will be 34 equal to 2d, that means d equal to 17 meter. So that means if a wall is more than 17 meter, then we will hear echo of our sound. Sound can have frequency of very wide range, few hertz to few thousand or even more hertz. Now, it is important to know that our ears have a window of defined frequency which they can detect or identify, and this window varies from, for a normal human being, on an average from 20 Hertz to 20,000 Hertz or 20 kilohertz. Normal human being can hear only sound which has frequency between this range. This is called audible sound. But sound can be less than this, from 0 to 20, and higher than this. This range, audible sound range, is also called sonic. When frequency is less than 20 Hertz, this is called infra-sound. And when it is more than 20 kilohertz, then it is called ultrasound. You would have heard these names in hospitals, ultrasound. Now, there are some animals which can hear infrasound and some of them can hear ultrasound. Say bat, cat and dogs, they can hear frequency which is more than 20 kilohertz. And elephant can hear, or whale can hear frequency less than 20 Hertz or infrasound. Now, sometimes people will get confused between ultrasound and supersonic, and they think both are same, but these are two different things. Ultrasound is when frequency of sound is more than 20 kilohertz or 20,000 Hertz, and supersonic, which is normally you will see when we talk about fighter planes. If speed of flying object, any object, if flying object is more than speed of sound, I will repeat, if the speed of an object is more than speed of sound, which is on an average 340 meter per second, then that speed is called supersonic speed. That means supersonic indicates speed while ultrasound indicates frequency. So guys, I hope this video was useful and you are able to understand basics of sound and you found this video interesting. Please keep writing your comment and recommend the topic which you want me to cover in coming up videos. I will be coming up with part 2 of this video where we will do some numerical questions and we will go in some more details. Thanks for watching.